Today, we're diving into the groundbreaking science and complex ethics of de-extinction. Imagine a world where the woolly mammoth once again roams the Arctic tundra, or the passenger pigeon fills the sky in breathtaking flocks. Sounds like science fiction? Well, it's closer to reality than you might think. Join me as we explore the cutting-edge technologies, the scientific wonders, and the ethical dilemmas of bringing back extinct species. Let's embark on this incredible journey together. Our story begins with extinction, the permanent loss of species that once thrived on our planet. Over 99% of all species that ever lived are now extinct. Some vanished millions of years ago, while others, like the dodo and the passenger pigeon, disappeared more recently. But what if extinction didn't have to be forever? What if we could turn back the clock and revive these lost species? Enter the world of de-extinction. Thanks to advances in genetics and biotechnology, scientists are now exploring ways to bring back extinct species. It's a process that combines elements of cloning, gene editing, and synthetic biology. But how exactly does it work? De-extinction is a multi-step process. First, we need a well-preserved sample of the extinct species' DNA. This can come from fossils, preserved specimens, or even frozen remains. Once we have the DNA, we can either clone the animal or use gene editing to insert its genetic material into a closely related living species. One of the most famous de-extinction projects is the attempt to revive the woolly mammoth. Imagine this Ice Age giant walking through the snowy tundra once again. The woolly mammoth, with its iconic long tusks and shaggy coat, roamed the Earth during the last Ice Age. It went extinct around 4,000 years ago, but its well-preserved remains have given scientists a treasure trove of genetic material to work with. Our goal is to use gene editing tools like CRISPR to splice mammoth DNA into the genome of the Asian elephant, the mammoth's closest living relative. By doing this, we hope to create a hybrid that can thrive in modern environments. But why bring back the mammoth? Is it just for the wow factor, or are there deeper reasons? Proponents of de-extinction argue that bringing back the mammoth could help restore the Arctic tundra ecosystem. Mammoths were vital in maintaining grasslands by trampling trees and spreading nutrients. Their return could potentially slow down the melting of permafrost by encouraging the growth of grasslands that reflect more sunlight. But de-extinction isn't without its critics. There are significant ethical and ecological concerns to consider. One of the primary concerns is the welfare of the de-extinct animals. How will they fare in modern ecosystems? Do we have a moral obligation to ensure their well-being? Additionally, there are worries about the unforeseen impacts on current ecosystems. Introducing a species that has been absent for thousands of years could disrupt existing wildlife and habitats. These ethical questions are crucial. Just because we can bring back a species, does it mean we should? Another high-profile de-extinction project focuses on the passenger pigeon. Once numbering in the billions, passenger pigeons were an iconic species in North America. Their flocks were so massive they could darken the sky for hours. But due to overhunting and habitat destruction, the passenger pigeon went extinct in the early 20th century. The Passenger Pigeon Project aims to use genetic engineering to recreate the species. By editing the genome of the band-tailed pigeon, a close relative, we hope to bring back traits of the passenger pigeon. Our goal is not only to revive the species, but also to reintroduce it into its former habitats. The potential reintroduction of passenger pigeons raises both hopes and concerns. Could their return help restore forest ecosystems, or might it cause unforeseen problems? Forest ecosystems that once thrived with passenger pigeons could benefit from their reintroduction. These birds played a crucial role in seed dispersal and nutrient cycling. However, reintroducing them into modern ecosystems, where conditions have changed, poses significant challenges. De-extinction also brings up broader ethical questions about our relationship with nature. Are we playing God by bringing back these species, or are we simply correcting past mistakes? The idea of de-extinction forces us to confront our role as stewards of the Earth. Do we have the right to revive species that went extinct due to natural processes, or should we focus solely on those that disappeared because of human activity? These are profound questions that require careful consideration. Another layer of complexity in de-extinction lies in its potential scientific benefits. Each extinct species represents a unique genetic blueprint that could offer valuable insights into evolution, genetics, and conservation. So what does the future hold for de-extinction? Will we see woolly mammoths and passenger pigeons in our lifetime, or is it just a distant dream? The technology is advancing rapidly, but we must proceed with caution. Successful de-extinction requires not only scientific breakthroughs, but also thoughtful consideration of ethical and ecological impacts. Collaboration between scientists, ethicists, and policymakers is essential to ensure that de-extinction efforts are responsible and beneficial. One thing is certain: de-extinction has the potential to reshape our understanding of life on Earth and our role in preserving it. It's a journey filled with challenges and opportunities, and it's one that captures the imagination. Imagine a world where future generations can witness the awe-inspiring sight of a woolly mammoth or hear the call of a passenger pigeon. De-extinction isn't just about science. It's about inspiring wonder and reconnecting with our natural heritage. As we continue to explore the possibilities of de-extinction, let's remember that our ultimate goal is to learn from the past and create a better future for all species, extinct or extant. The Earth is a tapestry of life, woven over millions of years. De-extinction offers a unique thread that can enrich this tapestry, but it requires us to weave it with care, respect, and wisdom. Now, let's delve deeper into the potential benefits and risks of de-extinction. Proponents argue that reviving extinct species can restore lost ecological functions, such as seed dispersal or habitat engineering, which are crucial for maintaining ecosystem balance. For instance, reintroducing mammoths to the Arctic could help mitigate climate change impacts by promoting the growth of vegetation that reflects sunlight and slows permafrost melt. Moreover, de-extinction projects provide unique opportunities for scientific discovery. Studying revived species can yield insights into their biology, behavior, and evolutionary history that were previously inaccessible. This knowledge can inform conservation efforts for existing species and ecosystems facing similar threats. Ecosystems have undergone significant changes since the disappearance of these species, raising uncertainties about their ecological roles and interactions with current fauna and flora. Such introductions could potentially disrupt local biodiversity and ecosystem dynamics, leading to unforeseen ecological consequences. Furthermore, the resources and efforts allocated to de-extinction could divert attention and funding away from crucial conservation measures aimed at protecting existing endangered species and habitats. Critics argue that conservation resources should prioritize preventing extinctions and restoring habitats for currently endangered species, which face immediate threats due to human activities like habitat destruction and climate change. Another critical ethical consideration revolves around animal welfare. Revived species may face challenges adapting to modern environments, potentially leading to suffering or diminished quality of life. Ensuring the welfare of these animals would require extensive research and monitoring to mitigate any adverse impacts of de-extinction efforts. From a broader societal perspective, de-extinction raises questions about humanity's role in nature and our responsibility to preserve biodiversity. Are we justified in resurrecting species that have long been absent from Earth? Or should we focus on safeguarding existing biodiversity and mitigating the impacts of human activities that drive species to extinction? These ethical dilemmas underscore the need for careful deliberation and comprehensive risk assessments before proceeding with de-extinction projects. Robust regulatory frameworks and international collaborations are essential to ensure that de-extinction efforts adhere to ethical standards and prioritize the well-being of both revived species and existing ecosystems. Despite the complexities and uncertainties surrounding de-extinction, the concept continues to captivate scientists, conservationists, and the public alike. The possibility of witnessing extinct species once again roaming their natural habitats offers a glimpse into a world where humanity's technological prowess intersects with our desire to restore lost wonders of the natural world. As scientific knowledge and technological capabilities evolve, so too will our understanding of the potential benefits and risks associated with de-extinction. Ultimately, the future of de-extinction rests not only on scientific feasibility, but also on ethical considerations and societal consensus regarding our stewardship of Earth's biodiversity. In conclusion, de-extinction represents a frontier in conservation biology and genetic engineering that holds promise for biodiversity conservation and scientific discovery. However, It also raises profound ethical and ecological questions that warrant careful consideration and public discourse. As we navigate the complexities of de-extinction, let us strive to uphold ethical principles, prioritize conservation efforts for existing species, and safeguard the intricate web of life that sustains our planet.